going to talk about the transmissibility and equivalent force principle. My name is Jimena Alejandra Martinez Perez.
My name is Luis Ángel Eija Montoya.
And my name is Diego Armando Trejo Piña.
The principle of transmissibility states that a point of application of a force can be moved anywhere along its line of action without changing the external reaction forces on a rigid. Any force that has the same magnitude and direction and which has a point of application somewhere along the same line of action will cause the same acceleration and will result in the same moment. Therefore, the points of application of forces may be moved along the line of action to simplify the analysis of rigid bodies like shown in the image below. The principle of transmissibility follows from this. Two forces that have the same line of action produce the same external on the body because they have the same net force and moment about any point.
Okay, now first we will analyze a simple system where we will apply in a simple way the transmissibility principle, and then we will analyze another one, complex system. We have in the system the point A, B, and C. Where there is a force of 20 newtons in the point A and two forces of 10 and 13 newtons in the point C. We also have the 0.5 and 1 meters respectively. Now to calculate our sum of moments, we will use the principle of transmissibility, where we will draw in an imaginary way the line of action of the force of 20 newtons. And in this way, we will obtain our rectangle. So this way would be able to use the Pythagoras theorem to know our distance between point A and point C. And once we have all our data, we can calculate our sum of moments, solving the operation respectively, and we have the results of 90 newtons meters. And we can calculate actually the sum of moments at any point, but we decided to do it only at the point C. And that's all. Now my partner will use the principle of transmissibility in another system a little bit more complex.
In the case 2, we have 5 forces in a plane. We will calculate the moment of each point of that plane. We have a force in A of 10 newtons, a force in B of 100 newtons, a force in C of 80 newtons, a force on F on 170 newtons, and a force on E that is 180 newtons. We have like distances of 1.5 between A, B, and C, and a distance between C and F of 3 meters, and a distance between F and E about 2 meters. First, we need to calculate the y distance and the x distance. For this, we'll need to use the law of sines with the sign of 50 and the distance between C and F. So we calculate that x is 1.93 meters and y is 2.3 meters. Then we need to calculate the moment of A. We have that the moment of A is the force on B, that is 100 newtons, and we use the distance between them, that is 1.5 meters. Then the force on F, that is 170 newtons, that using the principle of transmissibility, we need to sum 1.5, and the distance of x, because we move that force to the same horizontal line of A. So we have that is 4.93 meters, and the distance of A to the E point, that is 6.93 meters. Using all that multiplication and summing all the results, we have that the moment of A is minus 275 Newton meters. On the moment of B, it's the same thing. We use the force of F and F and the use of Fe, and we calculate the distance between the B and the F on the horizontal lane and B and E on the horizontal lane, using that is 170 newtons times 3.43 meters plus 180 newtons times 5.46 meters, and we have that the moment. The resultant moment of B is minus 394.3 newton meters. We use the same principle for C, F, and E. So here, to not use the Varignon theorem, there will be like if the force of B, the moment of F in the moment of B will be the distance between B and F on a diagonal, and the sine of the angle between B and F. So the principle of transmissibility help us get a moment in an easier way, moving the force to the horizontal or the vertical line of the point on the plane, then just multiplying the force times the distance between the 2 points, the two vectors, so that will get an easier moment for us to calculate. And that's all that it will be explained for the transmissibility principle. Thank you.